All right, well, I'm going to introduce Karen Magliano. Our next speaker is Karen Magliano, who is Assistant Division Chief of the Air Quality Planning and Science Division of the California Air Resources Board. Today, Karen will be presenting the topic of network design monitoring goals. Karen's division at ARB consists of 6 branches. These branches are responsible for developing state implementation plans, analyzing and distributing air quality data, conducting meteorological and air quality modeling, developing and maintaining states' emissions inventory of criteria and greenhouse gas emissions, implementing the program to reduce emissions from consumer products and architectural coatings, and responsible for the analysis of transportation-related emission reduction strategies, this one's more of a mouthful, to meet both federal standards and to meet California's greenhouse gas emissions reduction goals. Prior to this position, Karen oversaw the California Regional Particulate Matter Study. She managed the Particulate Matter Analysis section, and she was chief of the Air Quality Data Branch. Karen has both a bachelor's and master's degree in atmospheric sciences from the University of California, Davis. Please help me welcome Karen Magliano.
Well, thank you, everyone. Today I want to talk a little bit, sort of switching gears here, about how fundamental monitoring data is to ARB's programs. And I think we view ourselves in the Air Quality Planning and Science Division as super users for monitoring data, given the breadth of things that we do. And even though I have a blue dot on mine that says I'm in management, I know my staff in the division know that at heart I am a fundamental data geek, so I'm very happy to be able to talk about that with all of you today. So the collective mission, obviously, of all of our organizations is protection of public health. And air quality monitoring and meteorological monitoring data really do play a fundamental role in allowing us to accomplish that. And we do a vast spectrum of different kinds of assessment and uses of that data in order to support that. Everything from the extremely techie understanding air quality chemistry to the other side of the equation, where we're really trying to make that data real to the public and tell the story of what we've been doing, the successes that we have, and that the investments that we've all made have been worth it, but also how much farther that we have to go. So just a quick overview of what I'd like to cover today. First, a little bit about just the extent of the monitoring network that all of you work on. And some of the minimum monitoring requirements, though I know there will be more discussion of that in additional presentations. And then really focus on how do we use that data, both for regulatory purposes and a whole host of non-regulatory purposes as well. And then you've heard a little bit about it today from some of the other presentations, but what are some of the impacts of data that we have seen and how that's influenced our ability or not to be able to make regulatory decisions? So we have to start with the requisite map of where all the air quality monitoring sites are in the state. Since we're the friendly audience here, I would, I think, like to boast that we probably have the most comprehensive monitoring network in the nation and probably in the world. As you can see, we've got more than 250 sites with over 600 different types of instrumentation that are part of that network. And it's really designed to meet a number of different goals, which I'll talk about here. Everything from statewide monitoring with our greenhouse gas monitoring program that we've just started undertaking, to regional goals when we're looking at meeting air quality standards, and then down to the local level when we're starting to look at community monitoring and environmental justice concerns. And as Debbie was mentioning and others this morning, that there's an increasingly larger role for local citizens and community groups to be able to do their own monitoring, and that's something that we'll need to be able to work collectively on as we move forward, how to use and understand that data. So I'm not really going to say much about this other than One of the key elements, as you've all been hearing about the number of different kinds of documents out there, is that EPA has set a number of minimum monitoring requirements that the network must meet. And some of them relate to the number of sites that are required. And as you can see from that map that we had in California, given the diversity of the kinds of regions that we have and all the severity of our air quality problem, we go far beyond those minimum monitoring requirements. But there are also specifications for the types of instruments that can be used, whether they can be used for regulatory purposes or not, how they're cited, and then obviously very key are how you do the quality assurance for that. So one of the very first steps that we take in terms of using air quality monitoring data is to determine who meets the standard and who doesn't meet the standard, the whole non-attainment, attainment designation process. That is a regulatory action, both for federal purposes and for state standard purposes. And it does require that the data that we use for that process is fully quality assured, and also that it is complete and that it has been certified. And that means that every year ARB and the local air districts make sure that the data meets all those requirements and essentially do send a letter saying, I certify that the data qualifies as that. One of the things that we have found over the years is that it is very easy to be shown to be non-attainment. It is much more difficult to be shown to be in attainment, and that's where having complete data really plays a tremendous role. We may think that an area should be attainment, but we really need to be able to prove that's an attainment through good data. One of the other key aspects of that is that, well, we want you to all to pay attention to all of the monitoring sites in the network. There really are some sites that are more special than others. We call these the priority monitoring sites. These are often the ones that will drive regulatory decisions that are the basis for determining how much control we need to do and whether a region is going to be in attainment or non-attainment. And for these sites in particular, having a long and consistent data record is very important. We know sometimes sites have to move due to circumstances beyond our control, but the extent to which we can have a continuous data record at some of these key sites, it is very helpful. And as many of you know, we are working through a number of different issues where sites have had to move and have complicated decision making. So I just wanted to show a little bit of an example of what we mean by priority sites. Typically in air districts that have multiple air quality monitoring stations, you might see a range of concentrations. And the ones that typically record the highest concentration ones are the ones that are generally of the highest priority, because an area does not go into attainment until every single one of those monitors actually meets the standard. And so you can see the example here for Sacramento, where we've got 3 different monitoring sites. The one shown in green has met the standard consistently since the early 2000s. Another one shown in the blue dotted line met it in the last couple of years, but we still have one monitoring site that is above the standard. And until that monitoring site comes into attainment, we aren't able to work with EPA to get a redesignation to attainment. And so that top red site is a priority monitoring site to make sure that, especially as we get closer and closer to attainment, that we do have complete data so we can be able to make that demonstration. So once we know who meets the standard and, most importantly, who doesn't meet the standard, as Debbie talked about this morning, the next step is to develop the state implementation plans that will outline the series of strategies that we need to put together that will bring us into meeting that particular standard. And so data plays a very essential role in allowing us to put together those plans. We do air quality modeling to help us understand what the impact of various controls might be. But one of the first steps we need to do is run that air quality model for current conditions so we can make sure that it's actually producing the right answers for the right reason and compare it to real air quality data. We also use it to help provide a balance or a counterpart to the air quality modeling. because we know that no single tool provides the perfect answer. There are uncertainties in all of the different tools we have. And so in some of the more recent SIPs, EPA has strongly encouraged what's known as a weight of evidence approach, where you don't put all your eggs in one basket of the air quality model, but you also take an extensive look at all of the air quality and other types of information that you have out there to see what kind of story that's telling you as well. And hopefully they are corroborating each other in terms of saying, yes, this is working, this is where we need to go. But there also can be cases where the air quality data might suggest something slightly different is happening, and it sends us back to the air quality model to see what kinds of improvements we can do or how we can better reconcile the two together. Now, one of the aspects of putting together these air quality plans is that luckily there are certain days that we don't have to design control strategies around, which are known as exceptional events. And so these are things such as wildfires, high wind-blown dust events, or luckily not very frequently in California, but seismic eruptions and things like that. This is something actually they deal a lot with in Hawaii, given the volcanic activity that they have there. But essentially what this allows us to do is if we can put together a comprehensive documentation package that demonstrates that we would not have exceeded an air quality standard but for the extra emissions that are coming from this event, the wildfire smoke or the wind-blown dust, then you can sort of exclude that from the regulatory process. So data plays obviously a very key role in able to put together that documentation, because what we need to show is that there's a causal relationship between the event happening and air quality that we may see sometimes very far downwind. And so we need to look at the air quality data and the meteorological monitoring data to establish that relationship. So one of the ways that station operators in particular can be very helpful to this is that as you're the ones that are oftentimes out there in the field right where this is happening, if you can put down notations when you're observing things are happening, those can be very effective as we pull together a whole suite of documentation about what is really happening. It's kind of one of those, a picture is worth 1,000 words. If you have someone who says, I was there and I could not see across the street, that's a very useful piece of information. But even if it's not necessarily an exceptional event, the other way that it can be very useful to a data analyst is if you arrive at the monitoring site and you notice something has changed. There was earth-moving activity that occurred across the street, or something else that's a little bit unusual. Marking that down can really help us when we're going back and looking at data and saying, it changed, why did it go higher, things of that nature. All those little bits of other metadata are very useful to what we do. So in addition to attainment, non-attainment, and putting together the plans, we do a host of different analyses with all the data just to understand the nature of the problem and what is going on with air quality trends and tracking whether our programs are actually effective. And what we've been trying to do more and more is not just be able to say, data went down, data went up. Is really understand why is it doing what's it doing and really tell the story of what is happening. And so we've started to look more at what is the severity of the problem, what's the geographic extent of the problem, as you can see the examples of the map here, and how has that changed over time. As air quality has gotten better, how many more people are now breathing cleaner air, for example. And then, as I said, it also helps us sometimes with some very specific kinds of measurements, especially with PM speciation, for example. It can help us track the effectiveness of individual control programs. For example, some of the wood smoke tracers that are collected can be very effective in linking back to, as air districts implement wood burning curtailment programs, do we see a strong connection between that and trends in those species? So as we pull together all of this data analysis, we put that out to both the technical community and to the public in a variety of different formats. We have our annual Almanac of Emissions and Air Quality. It was on hiatus for a number of years, but we've recently brought that back because we know that it is used extensively by people to be able to look at trends throughout the state, both in air quality and emissions. Periodically, we do a report to our board that talks about, usually at the beginning of the year, what has been the progress over the past year, sort of highlight where we've come and what the upcoming challenges are, especially as Debbie talked about this morning. There's a continuum of standards, and we attain one, but then usually there's a new, more stringent one that's set that we need to continue to work harder on. And then there are also a number of other forums. Probably many of you are familiar with the annual State of the Air that the American Lung Association puts out every year, where they actually give letter grade rankings to air districts. In response to that, CAPCOA has started putting out their own companion document that comes out about a week in advance of that State of the Air that also talks about, from an air district perspective, some of the positive things that are going on, so that even if some air districts continue to get an F grade year after year, there actually is progress that's happening, and you're getting to be a high F instead of a low F. And then there are also a number of other kinds of things that air quality data plays a role in, going back to supporting health studies, as Debbie was talking about this morning, to make that correlation between ambient concentrations and the kinds of health effects that people see. It feeds into a number of our regulatory programs in terms of when are there riding seasons for off-road vehicles at off-road vehicle parks, or when do you use vapor recovery programs. It's also very critical as part of emergency response systems. The picture here of the Richmond refinery fire. Now that we're heading into the summer and given the drought, there's a lot of data collection that goes into responding to wildfires. And as we heard this morning, some ARB staff are already out as part of a response effort. And then there's also a number of things that are done to address specific environmental justice concerns. So now I want to switch gears a little bit. A lot of what I've shown to date are things where we've sort of used air quality data in a retrospective manner, after we've collected it and looked at long periods of time, for example. But there's also an aspect of it that's very important, especially for that engagement with the public, and that is the use of data in real time to allow people to understand what's going on today or what might be predicted to happen tomorrow, so that they can adjust their activities, especially if they have health concerns. Or there's increasing use at school districts and other places so that they can adjust whether they're going to have sporting events or they're going to allow the kids to go out for recess, for example. And so AQI and Air Now is one of the main areas where all of this data goes into on a real-time basis that people use. And again, this is another place to emphasize a role that we can collaboratively play with each other, and that is the more people that are looking at that data real-time, the more it enhances our QA aspects of the data. Because sometimes what we found is that we all know that instruments sometimes malfunction or get these odd spikes. And if people are looking at it real time, it allows us to quickly correct that so an instrument doesn't continue to drift, and then we're less likely to lose a larger period of data. It's also helpful so that we don't, every once in a while, get these odd purple spots on the map where someone calls up and says, what's going on? And it turns out it was just a data error, for example. That real-time data is also used to support a number of episodic type curtailment or control programs, such as our programs that deal with smoke management and whether it's a burn day or a no burn day for agricultural burning or prescribed burning. A number of air districts during the winter months have residential wood burning curtailment programs. Don't light tonight, check before you burn. And that morning or the evening before air quality data is very important in determining whether they're going to call those. And then, of course, the longer-term summer spare the air kinds of programs as well. So throughout all these different uses, obviously, air quality data plays a key role, and we need it to be both reliable, complete, quality assured, because it really informs our decision-making throughout the entire process of what we do, starting from the air quality designations to developing plans to tracking progress. One of the other areas I know you'll hear more presentations about is the annual network plans, and I think Bill touched upon it this morning, as also a way to be able to document what is going on. And as Debbie had mentioned, what we're finding more and more is that people are using these other avenues of data information to help question regulatory decisions that we make. And part of EPA being able to say, for example, that an area now meets the standard, they also need to be able to say that your overall network was adequate and that you've complied with all of EPA's regulations. So I wanted to just close with a little bit of a specific real-world example where there have been some concerns about incomplete data or data that was not conforming completely to the requirements, where it does have some actual impacts on regulatory decisions. I know Debbie talked about it a little bit this morning, and I think Gwen did it as well, and now I will also talk about data completeness and when you actually do makeup samples for PM 2.5. So I think you're sensing a theme here that this is one that is of particular importance to what we do in the world of PM 2.5, where missing just a few samples can really make a large difference. So here is an example calendar of when one is supposed to collect the PM 2.5 samples if you were on a 1 and 6 day sampling schedule. And then it's an example of when 2 were missed, the 2 red without the checkbox. And then the green are when makeup samples were made. The one on the 14th was done within the prescribed time frame. The one on the 26th was not. And so there are repercussions for collecting them on days that do not meet the requirements. And so what I wanted to show here is this real-world example of what happened when some of those makeup samples weren't actually collected on the correct day. So here, there were a total of 102 samples that actually were collected, but only 92 of them were ones that were collected on the correct days and that could be used in a design value calculation. And you can see here that there's about a 10 microgram difference in the 98th percentile just from the difference of those 10 days and where they fell. And there are a number of different ways where this has repercussions in terms of what we do. One, you can see on the design value that you see a large difference between whether you're attainment or non-attainment based on what the sampling that you did. It can also affect when we're trying to look at long-term trends. You know, if you have a sharp uptick because of this, is that a real thing, or is that really an artifact of not having good sampling? And so that's why, from our perspective, we want to collectively work together to make sure that we do have the best data set that is possible. So just in closing, just wanted to highlight, I think, some of the things that are coming up next with some of the other speakers. Jason will be talking about different kinds of networks and how they relate, along with Eric and Meredith. A little bit more on some of those minimum monitoring requirements. And then also more detail on those annual network plans, what goes into them, and the whole public process that goes into it. And I think that is it. Thank you. Questions?
refresh my memory. What is what does design value mean?
Design value is sort of a arcane terminology that we use, but essentially it's the concentration that determines whether you're in compliance or not with a federal air quality standard. Typically, they look at a 3-year period of data as a way to try and average out some of the year-to-year variability that you might see from weather conditions. With most pollutants, it's not the very highest value that you measure in a year. They will usually provide some allowance for expecting that you're going to get a few values over the standard. So, for example, when you're looking at ozone, each year you would take the 4th highest 8-hour ozone concentration. You take those 3 years and you average them, and then the concentration you get would be your 8-hour ozone design value. And then you would compare that number at the highest site of all your monitoring sites in an air district to the standard, determine whether you meet the standard or you don't meet the standard.